So Lownde's method of apportionment. You guys do. Turn around.
Sorry, I was just hitting on a bit.
Don't wear me out. Yeah, just. Gus, take out your notes. Or not Gus, Robbie, take out your notes, please. Oh, you do have them out. I'm sorry. I'm sorry. And you don't even have your phone out. Oh my gosh. I owe you an apology. Robbie, I'm sorry.
Dude, you felt like it.
Okay. So, all right. So the first couple steps are the same as they were for Hamilton's method or for. This is all kinds of messed up. First couple steps are the same as they were for Hamilton's or for Webster's. It's the last step that's different. So let's say that I have, I don't know, pirate gold. Yeah. So we're going on an expedition for pirate gold. This Mr. Taft? Yeah. Mm-hmm. Bye. Mason, you're needed in the office for a moment. So let's say the class.
Starts the truck.
Okay.
Cable's gonna pick up his knee.
He started.
Slap on it with a hammer.
He's going on an expedition for pirate gold.
Did you say that fellow's name for me one more time?
Lownde. Yep. Do you know there's an actual like pirate party in Iceland that's running for their election right now?
Really?
Yeah.
That's pretty legit, actually.
What do you mean?
Like like we have the Democrats and the Republicans. Iceland has the pirate party.
That's awesome. That's so sick.
So like, yeah. Anyway, okay. So let's say that for our expedition for pirate gold, let's say that's Tristan Owen.
I just want to end up with the treasure. Oh,
Yep. Let's say Tristan invested $30,000 of his own cash money. Let's say that Robbie invested $42,000 of his own cash money. And then let's say that Harley really believes in this expedition for pirate gold, and he invested $70,000
He put me in for like 95.
of his own cash money. Sure, I'll throw you in. And then Tristan Ian.
Man, for A.N.
Oh, sorry, I thought it was Ian. I'm sorry.
No, you're good.
Tristan Ian put in $95,000. He got a small loan from his father of $95,000.
Bruh.
Okay.
Yeah,
So what happened is these guys apparently know girls, so we'll throw a girl in here too. Rebecca. She.
$2,000.
You're like $16.
Sexist guys, come on.
No, she's been saving up coins for a while.
Let's say Rebecca put in. Let's say Rebecca put in $80,000.
Okay, I hate you.
Okay. So the class pooled all their money together, and then we went on this expedition down to the Caribbean. We found this pirate treasure, and then in this pirate treasure we found 175 doubloons.
How much money is this?
One of the blues must be like,
I don't know, all kinds of monies. So we found 175 doubloons, and we want to be able to equally apportion these to people based on how much money they put in.
I don't trust it.
So we're going to use Lownde's method to apportion them. So Hamilton's method we already know how to do. Webster's method we already know how to do. So we're going to go over how we would use Lownde's method to apportion the doubloons equally amongst these people who contributed to this expedition to the Caribbean that our Math and Society class can bankroll. So step number one is the same as it is for Hamilton's. You're going to find the total. So find the total. So we're gonna add all these numbers up. So 30,000 plus you, 42,000 plus you, 72,000, 95,000, and 80,000. We're gonna add all those up together.
317,000.
Whoa, 317,000?
Yes.
So our total is 317,000.
That's great.
I think they had already done it.
Yeah, you guys are fine.
All right, so $317,000. Next thing we're gonna do is we're going to divide, right, by the number of things. By the number of things.
Except on that first, this is the same thing.
I know, the first couple steps are the same as Hamilton or Webster's. So we're gonna divide by,
1.811.
and we're gonna round to 2 decimal places. So what is it, Harley?
1.811.
1.811. We're gonna round to 3 decimal places. Wait, do you guys
Go 3 decimal places.
do you guys disagree?
Is it on third step?
Yeah, hold on. 2, 3 divided by 175. 1.811. Or no, not 1.811. Yeah, it's 1,811.429.
I like what's happening.
That's fine. You don't have to like what's happening. It's still,
It's happening.
yeah. Okay.
Falling off a cliff.
So we're going to take this, divided by that, and we get 1,811.429. Make sure that you're rounding to 3 decimal places. The actual rules say round to a number of decimal places. I'm just saying round to 3. Okay. Step number 3, you're going to divide each part by this number. So divide each part by that number. By that number. So far, again, it's the same as Hamilton or Webster's. By that number. So Tristan O.N. would do 30,000
It's called the
divided by 1,811.429. And whatever we get back out, we're going to round to 3 decimal places.
16.
math is a glare.
What was that line next to your desk?
I actually can't. It's broken. So I can't,
Oh, that's alright.
I can spin this as much as I want to.
We can imagine it closed.
It's not going to do anything. I know you said it, Harley. I just want to do it really quickly. 1,811.429. So 16.562. 16.562. And then next is going to be Robbie. Is 42,000.
We're gonna actually 4 quarter.
We're going to have a quiz. And 42,123 divided by 1,811.429. So 23.186. And then we got Harley with his 70,000.
Wait, I'm so lost right now.
So I'm taking the parts, Robbie, taking each of these parts. So yours was 42,000, Harley's is 70,000.
Oh, okay, sorry. That was your total the first one. Alright. I was lost for a second.
And I'm dividing it by this number that I had right here. This is called the divisor, 1811.429. And I'm rounding my answer to 3 decimal places. So on Harley, I got 38.644. 38.644. So far, it's the same as with Hamilton or 429. Hamilton or Webster's methods. Tristan, 95,003 divided by 1,811.429. Jefferson's method requires you to do 3 or 4 different divisions, possibly. Divided by 1,811.429 for answers that aren't necessarily that different. So I don't really like Jefferson's method. 0.445. And then the Huntington Hill method requires a lot of square roots. So I think it's needlessly complicated in my opinion. 80,000. So far we haven't done any steps different. Mason?
Check.
429. So 80.23 divided by 1811.429. All right. So now I'm not going to forget the decimal, but I'm going to look at it without the decimal for a second and see where I'm at as far as the number of doubloons. And then to figure out where I'm going to put the extra, I'm not just going to blindly add it to whichever one has the most, like I would with the Hamilton method. So right now I'm going to forget about the decimals for a second, but I'm not going to like erase them. So I'm just going to say that this would be 16, this would be 23, this would be 38, this would be 52, and this would be 44. But I'm not going to forget about those decimals right now. So if I were to add these up without the decimals, I'm going to look at how many doubloons I would have. So I'd have 16 plus 23 plus 38 plus 52 plus 44. So I'd have 173. So how many doubloons short am I? 2. So I'm not going to just blindly add the doubloons to these. Instead, I'm going to use the decimals here. No, that would be Webster's method. I'm going to use the decimals to decide where the extra doubloons are going to go. And here's how Lownde's method differs. So step number 4. Divide the decimal part by the number part. And what I mean by that is I'm going to do 0.562 divided by 16. I'm going to do 0.186 divided by 23, 0.644 divided by 38, 0.445 divided by 52, and 0.164 divided by 44. So I'm going to and round that to 3 decimal places as well. So 0.562 divided by 16, I get 0.035. 0.186 divided by 23, I get 0.008. 0.644 divided by 38, I get 0.017. 0.445 divided by 52, 0.009.
These are all still the same steps, right?
No, this is the new step. 0.164 divided by 44. And I get 0.004. All right. So now, step number 5. Give the extra to whichever new number is highest. So by new number, I mean the stuff that's in this column right here. So which of these new numbers, 0.035, 0.008, 0.017, 0.009, and 0.004, which of these new numbers is highest? So 0.035 is one of the highest, and then what's the next highest? Because I have another one to give out. 0.017, right? So this one's going to get one of the extra doubloons, and this one's going to get another of the extra doubloons. So the final answers are that Tristan Owen is going to get 17 doubloons, Robbie's going to get 23, Harley's going to get 39, Tristan Ann is going to get 52, and Rebecca's going to get 44.
Actually,
Okay? So Lownde's method, the first 3 steps are the same as for Webster's or Hamilton's, but the extra step is you take the decimal part divided by the whole number part for each of these, and then if you have extra that you have to give out, you give it to whichever of these are highest. But that's only if you have extra you have to give out. If you don't have extra you have to give out, you're fine. Kind of, sort of? All right. So just for funsies, because you guys asked,
Oh,
I was just about to look that up.
gold doubloon worth 16 more than 2 centuries ago, expected to fetch at least $5 million at auction.
For one?
That's what it says.
Bruh. I'll take my 23 now.
20 years.
5 times. Wait, if you get 23 of them,